Hey guys, I hope you guys well. Just change a little bit. Last lesson for week 2. I'm going through section 3, factorization of polynomials. Probably just do halfway through. Okay, so I'll introduce remainder theorem, factor theorem. We've done it long division, and then we'll do short division together. That's it. So synthetic division, I will teach you next week. So I'll leave it that way. From the start, let's use the booklet quickly, so I don't have to write down everything. Can you see that? Yep. Okay, remainder theorem. Can you read that first quickly? Okay. What they explain here, let's do this together. Let Px x cubed plus 3x squared plus 2x plus 1. When we divide by this by x minus 2, so and then we divide by x minus 2. So using long division, can you do that in your exercise book actually? Yep, check your long division skill. When you do it, we'll have eventually quotient is this, and dot 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 dot, remainder gonna be 25. Okay, and then I can write down this is equal to x minus 2 x squared plus 5 x plus 12 plus 25 over x minus 2. We done that last class, wasn't it? Yeah. Write down remainder, divide by, make sure divisor over divisor. Okay. But at least I know remainder is 25. Okay, we get that. Let's try this one now. X, let's use this. Minus 2, that's divisor, which means what makes equals 0? X minus 2 equals 0 when x equals what? 2, isn't it? Yep. So now I put 2 into that polynomial. For example, px, according to this, px equals x cubed plus 3x squared plus 2x, that's square. Write it down. Yep. Plus 1. And now I know when, let's put, well, we don't know, but we can put x equals 2. P when x equals 2 times 4, 12, 4, 1, 5, 13, 25. What do we get? 25, which is same as the remainder. That's the remainder theorem. Okay, let's go back and check that. The example suggests that when px is divided by x minus a, the remainder is equal to p bracket a. Whatever the thing we put in a, we got the result, isn't it? The result is going to be same as remainder. It always come up that way, and we call that's remainder theorem. Make sense? And they actually put extra information here. So what about if this was x minus a form, then I can put a here, wasn't it? Yeah. What about if this one is ax plus b form. Still the same thing. The logic was we make x minus 2 equals what? 0. Yep. So ax plus b equals what? 0. Ax equals minus b. X equals minus b divided by a over a. So that's what you're gonna see. So I put polynomial when x is minus b over a. So that's what you can put in with different ones. Okay. So that's written here. When x is form x minus a form, we put that a here in polynomial. If that's ax plus b, all you need to remember is that makes equals 0. That makes equals 0. Then you will find what you can put in that polynomials. Sounds good? Yep. Okay. Let's just try that. So we did that. Can you do example 9? Can you do example 9? Yep, I know it's all there, so hide that and do it in your exercise book first. Pause it and do it. Okay, how was it? I think that's pretty simple and not easy, wasn't it? Divide by x minus 2, therefore x equals what? X minus 2 equals 0, x is 2. So we plugged in 2 here, and we got 6 there. Okay, and then second one, we can make 2x plus 1 equals 0, 2x equals minus 1, x equals minus 1 over 2. Okay, and then all I need to plug in minus 1 over 2. So following that, and you will get 39 over 8. It is the pretty simple thing. Next question. When px equals 3x cubed, x cubed plus 2x plus a is divided by x minus 2 and remainder is 4. Okay. Now I don't have to actually divide it. I can use what? Remainder theorem. I can use remainder theorem, which means x minus 2 equals what? 0, therefore x equals 2. I can put 2 into what? Polynomials. 2, 2, 2, and I'll just write down. Then that will be what? Remainder is 4, which means our result has to be 4. According to what? Remainder theorem. Good. 8 plus 4a equals same as what? The result has to be 4. Minus 4, 4a, therefore a equals minus 1. Oops! What did I do wrong? Oh, this is plus, guys. Sorry. This is plus, not times. This is 4 plus a. Sorry, guys. Cancel that out. Minus a. A equals minus a. Correct. Now, feel free to make small mistake. That's okay. But yes, it's plus there. Well done, Charlie. Good job. Vector theorem is strongly related with that. But at this point, so I'm asking you, can you explain what is remainder theorem? Speak out. I can hear you. I'm even acting now. I'm getting used to talking alone. Okay, that's it. Make sure you can tell me or tell yourself what is remainder theorem. Okay, you need to be able to explain it. Let's go to the booklet. without actually dividing. Yes, using remainder theorem, we don't have to divide it, okay? And dividing takes much longer time. When we use remainder theorem, you can get remainder much faster. Find the remainder without dividing. What do I need to use it? Without dividing, find the remainder. I need to do px equals something. We can get remainder, isn't it? Yeah. And according to what? Remainder theorem. Good. So this one is divided by that. That will make equals 0. X equals 3. That means I can put 3 instead of x. Substitute 3 into x. Polynomial. Px same as fx. I just look at it as a function. Then I can use f. We keep using p because this is polynomials as well. Okay. And it plugged in 3, 3, 3, calculated, what did we get? F3 or P3, the result is minus 38. Okay? When x is 3, I can actually draw that. I mean, this is not relevant to this, but I've just expanded. When I don't know, I'm not able to draw that yet, but I know when x is 3, y value is minus 39. So that will pass here. That curve will pass that point. Okay, the point is on that curve. Okay, and that is what is same as what? Is it 38? Yep, 38. Same as remainder. That's what people found. Same as remainder. The y value is same as remainder. It's quite interesting, isn't it? Yep, exactly the same number. Without actually dividing, find the remainder. What do I need to use? Remainder theorem. That means I need to put polynomials here. So I need to go and find that value, which is makes 2x plus 1 equals what? 0. Good, guys, good. So 2x plus 1 equals 0. 2x equals minus 1. X is minus half. Good. You can use that, but I think in this case, all you need to remember is make equals 0. Good. Plugged in. I already did it. I know I became a bit lazy. I usually wrote down and do it again, but I think this is simple enough, so I'll just leave it that way. I got 21 over 4. The result of your Px, that is same as what? Remainder. That is remainder theorem. Can you remember that? Okay, excellent, guys. Next one. The remainder when x cubed plus k, x squared plus x minus 2 is divided by this equal to 20. Find the value of k. It is basically same as what? Example 10. It's very similar one. Can you do it first? Can you do it first? Pause it and do it. Do it. Okay, you're done, right? How was it? Simple enough. If you're not sure, go back to example 10. You can check how you do it. So when x minus 2 equals 0, x equals what? 2. So when I put 2 into that polynomial, I should get blah 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 equals what? 20. Okay, so I'll make 20 equals that. And solve it. K equals 3. Who get k equals 3? Hands up. Good job. Good job. Next one. Let's go to factor theorem. Can you go to page 257? Now, Joe, can you read factor theorem? Good job. No, just try to entertain myself. I think it's 2 weeks now. I miss you guys. I try to pretend, should invite someone in front of me and actually teach. Anyway, all right, continue. Now, in order for x minus a to be a factor of the polynomial x, the remainder must be 0. Oh, so when according to remainder theorem, if something divisor is x minus 3, let's say that, and that makes 0 equals x equals 3. So when you put 3 into that polynomial, we will get the remainder, wasn't it? That's the remainder theorem. And according to factor theorem, if that x equals 3, when I put 3 into the polynomial, when I solve everything, has to be equals what? 0. Which means your remainder is 0. That become a factor. True. The fact. Go back to previous videos. I talked about probably last video. Don't know where I actually talked about that. I'll just put this here. Now let's go through this first, and then I'll use example and explain what I just talked about. Okay? For a polynomial px, when we put a instead of x, actual number equals 0. If that equals 0, which means remainder is what? 0. So I can divide by something completely. That makes a factor. That makes sense. X minus a is a factor of px. Okay. You can just see that it's the same thing. Makes equals 0. So I won't talk about it. In this case, I will do that example 11 with you. Example 11. Okay, I did it. X plus 1. Show that when they start with show, which means prove it. So just solve it. X minus 1 is a factor. That means already I know x plus 1. What makes x plus 1? X plus 1 equals what? 0. X equals minus 1. When I put minus 1, substitute minus 1 into that polynomial, the result has to be what? 0. Okay, that becomes a factor. The remainder, remainder is 0. Okay, which means y intercept is 0, which means that become wherever the factor is 1, 2, 3, for example. I haven't told you that yet. That become x-intercept. Okay, the factor means in this case minus 1. That is become x-intercept. We'll leave it there. I'll teach you again this one. And if we solve it, minus 1, minus 1, minus 1, minus 1, you plugged in, that equals 0. Okay, therefore, minus 1 is a root, and I write down x plus 1. That makes sense? Yep. So, if minus 1 is factor, all you need to do, x, and then change the sign. Or think this way, x, hold on, what's the best way? Minus 1, okay, so probably look this way, x equals what? In this case, x equals minus 1, isn't it? Yep, and we're going back to opposite way. We want to make that equals 0. So x, when I move to it, plus equals 0, Therefore, I can get x plus 1 as well. That's another way if you confuse it, yeah, or just change sign. But you can think of that way. They actually explain the whole thing here. They actually go a bit further, which I'm gonna mention later. Okay, or leave it that way. So as long as you understand this part, I will be happy. They said find the other linear factors, which means you have to do short division, which is the page here. You maybe come back and continue, or you can have a look later after we learn short division. Okay, let's go back to our booklet. The factor theorem. Now you understand, with that is 0. Okay, we can write it down. Apply the factor theorem to determine if this and that are the factor of this, which means x plus 2, when I plug that in, that will make something 0, isn't it? Yep. X is minus 2. I can plug in minus 2. X minus 1 equals 0. X equals 1. So I can plug in minus 2 and 1 into polynomial. And then that also has to be 0 and 0. This is both the factor. They're both factor, so it has to be 0. Oh, you actually determine. Sorry. You don't have to show determine. So you find out whether this is a factor or not. Okay. When I plugged in minus 2 and calculate it, you will get equals 0. Therefore, x plus 2 is a factor since the polynomial becomes 0 when I plugged in minus 2. So when you write it down, you should write down this way. That dot x plus 2 is a factor. Okay? Or if that's a root, I can say minus 2. X equals minus 2 is a root. That's another way you can express that. But we keep using the factor, so please follow this way. Okay? That's also correct too. When x is 1, we plugged in all the way through here, you will get 252. They are not equal to 0, therefore x minus 1 is not a factor. Good? Okay, next one. I've done that. That's a short division. Let's do the long division first. Long division, which we already learned, isn't it? Use long division, factorize this, so that divide by x minus 2. Where did I get the x minus 2? Usually probably given, but when they ask you long division, but if it's one factor is not given, you have to go and find the factor using trial and error, which means you basically plugged in all the numbers. But the easiest way is start from 1. You can see minus 1, 2, minus 2. Usually you can continue 3 minus 3, but somewhere here you will see one number. In this case, when I put x equals 2 minus 19 times 2 plus 30, that will make equals 0. Therefore, x minus 2 is factor. Okay? Alright, we write this. X equals what? 2, isn't it? we'll make that 0. X minus 2 equals, to move this, 0. Therefore, x minus 2 is a factor. Okay, make sure you're able to change it, or just opposite sign. That's another way you can think of. Okay, x minus 2 divided by x cubed minus 19x plus 30 divided by x minus 2. You do it. I made mistakes over there, and then all the way through you should get 0. Okay, that's a factor. Then I can write it down. This is equal to x minus 2 is a factor, and then I will get something else. This times that has to be cubed. Therefore, I know here is quadratic formula. Okay, quadratic formula, something like ax squared plus bx plus c form. Also, I can get it using this, but I'm not doing it here. I've done it already. Now, I will do this. I'll show you that from short division. Okay, from short division, because that's short division. Okay, but at least you can tell. Use long division. I can factorize till here. Okay. After we learn short division, we can go back and do this. Short division. Another method is short division. First, this is a bit faster. A factor of polynomial has to be found using a factor theorem. Okay, so in this case, our example here has a factor is x minus 1. Therefore, or if it's not given, if no factor given, what do you need to do? Trial and error. You have to put 1 minus 1, 2 minus 2. In this case, I realized when I put 1, that became a 0. So now x minus 1 is a factor. Okay, so the px is equal to x minus 1 and ax squared plus bx plus c. Alright, that's what we need to figure out. Since that's linear, I know linear times x squared will give me cubic function, isn't it? That's why I can assume that is what? Yep, quadratic. Good job. And then how we do, you compare. Let's do that. X minus 1, that's how I do. X times what squared number will give me what? X cubed, isn't it? There's only one way I can get x cubed is x times ax squared. Okay, the first one, x squared, x times x squared will give me x cubed. 1 times 1 is 1. So I just compare, get that. So I complete that. Easy. And the number is same. Number times number, c, will give me what? 10. So minus 1 times c equals 10. Minus 1 times c equals 10. Therefore, c has to be minus 10. So I don't know. That should be bx minus 10. Easily comparing highest power and just number, I can get this. All good? And then next, what you need to do? How can I get squared number? 2x squared. When I times x squared, I got x cubed. No, x times bx. When I times that, bx squared, I got the square number. Let's go. And then x times minus 10 is minus 10x. It's not the square number. We don't have to worry about. Minus 1 times number times x squared will give me another squared number. The other one compared? No. There's only two chances I can get squared number from this combination. So b minus 1 x squared is 2x squared. So therefore x squared I just only compare front part. 2 equals b minus 1. Therefore b equals 3. So I know that b equals 3. X minus 1 x squared, b is 3 plus 3x minus 10. Okay, so that's I factorize it linear and quadratic. But if the question asks you, like going back to page 257, look at the question. Hence, find the other linear factors. Linear factors. That's linear, however, that's not a linear. So I need to factorize more to find linear factors. X minus 1, let's think about this. Separate it. Usually, if you're able to do it, 5 times 2, 10. When I add it, that has to be 3. We have minus. I need to decide put minus where? Smaller number. So x plus 5, x minus 2. So that x squared plus 3x minus 10. When I factorize it, I get x plus 5, x minus 2. So I just plug in here x plus 5, x minus 2. Linear, linear, linear. So I get 3 linears. X times x times x, that's why I got x cubed. Okay, I have 3 factors. 1, 2, 3 factors. Based on that, when x equals 1, minus 5 and 2, the remainder going to be equal to 0. Okay, or px going to be equal to 0. There are 3 roots, 3 answers, or 3 x intercepts. The same thing. But in this case, do you understand what is short division? Let's have a look at this one. That will help you. It will solve more questions though. Example 6. Can you do that example 6? Okay. What's a bit harder? I mean, factorize using short division. If they ask short division, you have to use short division. Otherwise, you can just pick anything. What you can do doesn't really matter. However, nothing given. Doesn't matter it's long division or short division. The factor is not given. You need to find first one factor first. How? Trial and error. We just put 1 minus 1, 2 minus 2, usually somewhere here. Okay. In this case, I put 1, 2, and minus 2. When I put minus 2, that was a 0. Okay. That means, what does that mean? X minus 2 or plus 2? Plus 2. X equals minus 2. Therefore, x plus 2 equals 0. Make 0. That is a factor. X plus 2 is a factor. The root is minus 2. Okay? Therefore, x cubed minus 5x squared minus 2x plus 24 equals x plus 2. Okay? Times what? We should have here quadratic equation. Since x times quadratic will give me cubic function. Good. So I start from x squared, isn't it? Let's go and find it. Do I need any number in front of that? X times x squared is 1. Therefore, this is 1. Same. All I need to do, compare this highest degree. Then I can get this. There's only one, right? Another thing, plus bx. You can write down anything, okay? ax or bx, doesn't really matter. Plus number, square x number. So next one is number, which means 2 times number, gonna be 24, isn't it? Yep, to get 24. 2 times what will give 24? 12. So you straight away you can get this and that, worked it out really quickly. And then I compare next one, x squared minus 5x squared. How can I get minus 5x squared from here? X squared number times this, 2x squared, and obviously one more thing there, x times bx plus bx, x times x squared. So minus 5 equals 2 plus b. b equals minus 7. So that has to be minus 7. Now I have x plus 2, x squared minus 7x plus 12. I factorize it. I haven't finished it. I'm going to get linear factor. I can go a bit further. Right hand side one. 12. 4, 3, 12. Times it. When I add it, I get minus 7. That means negative, negative. X, x. Therefore, same as this. X plus 2, and when I factorize it, I get that. Okay, so I have 3 factors, x plus 2, x minus 4, x minus 3. And I have 3 roots, minus 2, 4, 3. When I put minus 2, 4, and 3, I will have equals 0, the remainder 0. According to remainder theorem, x equals minus 2, 4, and 3. Or. Okay? All good? Just done that. Oh yeah, it's here. I just did it. And then next one, hopefully you can do it. First, trial and error method. Put 1 minus 1, 2 minus 2. You can work that out. What makes equal 0? In this case, when x is 2. Therefore, a factor is what? X minus 2 is a factor. Okay? X minus 2 is a factor. That means I can set up x minus 2 and then try to make that 2x cubed, therefore 2x squared. 2 times 1 is 2. Yeah, and then figure out number as well. Minus 6. Minus 2 times what will give me minus 6? 3. And then I use a here, doesn't really matter, it's just letter. Again, same thing. What should I give me? 3x squared. Minus 2 times 2x squared, so minus 4x squared. And then x times ax. So ax squared, therefore, that's what I get. This a equals 7. Therefore, hold on, what am I doing? A is 7, so now I get it previously, now a is 7. And then all I need to do, factorize that again to make linear factor. So 2, 1, 1, 3, 6, 1 becomes 7. Therefore, x minus 2, 2x plus 1, and 1x is x plus 3. Okay, so 1, 2, 3 linear factors I have. And the answer is x equals 2 or I will make 2x plus 1 equals 0, half, or minus 3. That's how you can write that down. Okay, that's synthetic division, so we'll leave it there. But let's go back. I spent lots of time explaining short division. Yeah. For long division, when I complete that, long division, you actually divide. Okay. And the last part here will be the same. 5, 3. So you make the linear factor. You complete the last bit. It is the same. Yeah. But short division, you go and find, if it's given, you use that. Otherwise, you go and find trial and error. You find one factor, and then you can just compare original equation and what you just made it. And then you can go further factorizing. So you can get that. Hopefully, this makes sense for you. Otherwise, please use example from book. Book will explain pretty well as well. Today, go and solve section 3. I haven't done synthetic one, but you're still able to solve most of question unless they ask you to use synthetic. Okay, so you can solve question using short division or synthetic, either way. Okay, this is just another way you can do it, but we should able to do one question using long division, short division, and synthetic division. But we'll talk about synthetic next week, first class. Sounds okay? Also, I upload assessment 4 solution, so make sure you go through that video, check with your own assessment. Okay, if you now hand it in to me, I will give you B or C, depends on the time. Okay, I received lots of assessment, but not everybody handed in. Okay, if you hand it in now, you're not gonna get A, but I'll still give you some marks. All right, thanks guys.